I haven't recorded it. So after we find negative 3 power 4 is the same thing as negative 135. So we've got to go backwards 135 degrees, which gets me. So I need to look at 225 degrees. So what's my x and y at 225?
Negative root 2 over 2 and negative root 2 over 2.
Oh my gosh. Okay. I know. So, our next thing to do is write the cosine of theta down. Cosine. All you've got to do for the cosine is look at the x value. This is the x value. Cosine is the x value.
Cosine is the x value. You got this.
So
Okay,
all I have to do is write down negative root 2 over 2.
Does that mean the sine is the one thing?
That would be correct.
Yes, I got one right.
Oh, Gary, good job. Here we go. We recorded this.
So the sine, the y value, that one right there. All I got to do is write it down. So on your test Friday,
If I get it wrong, I'm gonna laugh.
since you have the circle there for you to look at, there should be no. I mean, once you figure that out, if it's positive, then it's really easy. You just look straight at the positive circle. I mean, you should get those two right, if nothing else, and you'll get partial credit for that at least.
Yeah.
I like popular 33 lessons.
So tangent is y over x, which would be.
Negative root 2 over 2
Which
over
would be
negative
I don't have enough room.
We just won.
Right. So negative. Can somebody not see that?
That color though.
That
That brown
is
color.
the color.
What?
Where's that
She
brown
doesn't
color
know what
line
she's
go?
saying.
I know what she's thinking. Taylor knows what I'm saying. I know what you're thinking.
That color doesn't look right. Not at all.
If I'm watching these notes, I don't know.
All right. Negative root 2 over 2
They kind of confused me with this one.
divided by negative root 2 over 2.
So it
Equals 1.
number divided by itself is 1.
Well, you should. If I have the same thing on the top and the bottom of a fraction,
It's just gonna be one every time like that.
only the 45. Every 45 degree angle. So 45 degrees, 135 degrees, 225,
315.
and 315 are all going to be 1, except it could be positive or it could be negative.
Gotta be
Right.
like that.
If the x and y are both negative, then it'll be a positive
Is
1.
it all the 5 degrees? Like,
Okay. So once we found those three, the other three are really easy. Secant goes with cosine. All you have to do is the reciprocal.
I love that color by the way.
The reciprocal is important for us to note here. When we do the reciprocal, this is the one on the left is negative. Cosine is negative. That doesn't mean this needs to also be what? Negative. The reciprocal doesn't change the sign. Okay, so yeah, it will. It does it automatically. So the cosecant, I just flip. The sign still has to stay the same.
Did you just start the entire recording?
Cotangent is just 1, because if I made this one 1 over 1 and I flip it, it's still 1 over 1. I just flip it. So does anybody got any questions? Okay. Here it's going to ask you to use the period as an aid. Y'all don't know what the period is,
No, we
but that is what that word says. I know you can't really read it.
I can.
Use the period as an aid, all right, is what we're wanting to do. But don't worry about that. On this problem, all you need to do, all right, is we don't want to do -8. Oh, that should have a 3 on the bottom.
Okay, yeah, that makes more sense.
Should be 3 on the bottom. Otherwise, it'd just be 2 pi.
Yeah, I agree.
Oh man, I meant to still have that orange.
That's the one I got wrong.
Alright, I just want to take 8 and divide it by 3 because I've got 8 over 3. So I want to take the 8 and divide it by 3. Okay. Like, it goes in there twice. I'm not really worried about how many times it goes in there. All that means is that I went around the unit circle twice. But I don't really care about that. Alright, that's 6. And my remainder, though, I do care about. I need my remainder. The remainder is going to be my new numerator. So I won't have the sign of negative. Since this was negative, it's going to stay negative over here. Alright, negative 2 pi over 3. So is anybody confused on what I did thus far? So I needed the remainder to get a new numerator, but my negative still stays the same, the pi is still there, the 3 is still there. The only thing I'm changing is that 8 to a 2. And how I got that 2 was the remainder when I divided. Does anybody have any questions about that? Okay. We can't stop here. You have to tell me what the sign of negative 2 pi over 3 actually is. So it's the same thing we did in this previous problem, except instead of doing all 6 of these, I only need you to do this one value of sign. Oops, I thought I still had the pointer on there. Alright. You have to do this one value of sign. That's all I'm asking you to find. So negative 2 pi over 3, alright, is the same thing as negative 120 degrees.
And that'd be 240.
So negative 120 is the same thing as 2. So I need to look at 240. And I need the y value.
Negative root 3 over 2.
And it's negative root 3 over 2. So on the test, I need you to show me that you know this somewhere. That you're looking at this angle, and then I need this value.
So you don't have to write all of it?
On your homework, number 8, there was a typo. I should have had a negative there with a 4, because you can't have a positive cosine in the third quadrant. Alright. On these problems, it wants you to draw a triangle. This is where we have to use SOHCAHTOA. Always start on the origin with these problems. Always start on the origin. And come straight out from the origin with your line. Then here, a lot of you, not a lot of you, but some of you want to connect this line to the y-axis. I've got to connect it to the x-axis. It'll always connect to the x-axis. So my triangle's there. That's a right angle. The angle that I'm looking for is always the one closest to the x-axis. That's my angle that I'm looking for. Anybody got any questions about that? How to draw? Always come out from the origin and always go down to the x-axis. Alright, so now I need to know what cosine is in SOHCAHTOA. Cosine of theta is adjacent over hypotenuse. So, adjacent would be equal to negative 4, and the hypotenuse would be 5. So my adjacent side is always the side with the x-axis on these triangles. Like on this triangle over on your quiz on Tuesday. Okay. So the adjacent side here is negative 4 on top of the x-axis there. And that's the opposite. There's the hypotenuse. Hypotenuse is 5. And then I have to find the other side, which in my case I should know because it's one of those special triangles. It's a special triple. So it's negative 3, negative 4, and negative 5. Positive 5, sorry. I'm going to explain that. Okay. Look, we have to, the reason the hypotenuse of these triangles are always going to be they're always going to be positive because it's like a length. These are technically lengths. Like if you were finding the length of the side of a triangle, it would always be positive. Since we're talking about this coordinate This is talking about the x-coordinate here. All right, the x-coordinate is -4. So I come across, so that's why this is a -4. If I was graphing any value over here, and I go to the left side of the graph at all, anywhere on this left side of the coordinate plane, the x values are negative. So, and then after I'm on the left, if I go, oh goodness gracious, what's the bell already? Alright, we'll finish this tomorrow. Okay, so what we need to do now is just find the other 5 trig functions. So the sine of theta, sine, SOH is opposite over hypotenuse. So the opposite is -3 over the hypotenuse, which is 5. So then what we've got to do is find the tangent, because we've already found the cosine. So the tangent of theta, tangent TOA, T-O-A, is opposite over adjacent. So opposite side is this -3, -4 on the top is the adjacent side. So opposite over adjacent would be -3 over -4. And a negative over a negative makes a what? So tangent should be +3 over 4. So does anyone have any questions about anything that I've done so far? About any of this? I'm testing the limits of this technology. So are we done though? No, we have to find the other 3 trig functions. Right? It already gives me cosine. What goes with cosine? Secant. So secant theta goes with cosine. So all that means is I need to flip the cosine. But it still stays negative, so it's going to be -5 over 4. Alright, the sine, what goes with sine? Cosecant. Cosecant goes with sine, and cosecant, you just flip the sine, so it's going to be -5 over 3. Then cotangent goes with tangent, and it's going to be 4 over 3. So are there any questions? Let's review how to simplify. We're going to do 2 of these, one with a square root, one with a cube root. Alright, so let's do this. So this one would be number 3. I'll post the work because I'm grading your homework. If you want to look at this homework to have practice problems, I'll post this homework on the school website. So you can get the file and look at it. So in this would be number 3 on the simplifying part. It's 54x. Okay. The first thing that we need to do is break down the 54. Alright, I can break that down into 9 and 6, or however you choose to break it down. 9 and 3, and then 6 breaks down into 3 and 2. Is anybody confused on what I've done so far? All I did was make a factor tree. So, my answers when I'm simplifying square roots, my answer is going to have a radical in it. Alright? So I may not have to put any, if I don't have to put anything under the radical, then I can just erase it. Alright? So, but what I need to do is find pairs. The reason I want to find a pair is because right here there's no 3 or a 4 or a 5. If there's nothing there, then it's understood that there's a 2. So I need to find pairs. And I have one pair of 3s. A pair of 3s. Pair of 3s. So I'm going to have 1 3 outside the square root. Alright. Then I have a 3 and a 2 left over. Anything that you have left over, you need to multiply together and put back under the radical. So 3 times 2 is 6. And it's going to go up under the square root. Anybody confused on where any of those come from, or what I've done so far? Alright, that's really the hardest part about simplifying. The letters are a little bit easier, because then I just need to take the exponent of the letter. I need to take the exponent of the letter and divide it by whatever my radical is. Since my radical's a 2, which is a square root, I need to divide each exponent by 2. So the exponent of the x is a 4. 4 divided by 2 is 2. So my x on the outside of my square root is going to have a 2 as the exponent. There's a remainder. I don't have a remainder when I divide 4 by 2. So really you could say that there's x to the 0, but x to the 0 is just... What is something to the 0 power? 1. So there's really nothing. I mean, I don't have to put any... There's no remainder. I don't have to put an x up under there. Alright. Y to the 5th. 5 divided by 2. Alright. 2 will go into 5 twice, so my y on the outside has an exponent of 2. And I have a remainder of 1, so y will have 1 y on the inside. Any questions so far?
Just fine.
Then I have to divide 7. Divide 7 by 2.
3.
Yep. So
Remainder.
3, and then 1 remainder of 1. You don't have to write those ones, but it's okay if you do, but they're really not, you don't really have to have them there. I'm just writing you so you know what to do with the remainders. Okay, so a cube root, we follow the same process that we do with a square root. We want to break down the number first. So I want to break down the 54. I break down the 54 into 9 and 6 again. Then 3 and 3, 3 and 2. Except this time I'm not looking for pairs. I'm looking for triple, a set of 3. Alright, so I need to look for a set of 3. I have a set of 3 2s. I mean of 3 3s, sorry, said the right thing. Okay, so same thing with a square root. My answer is going to have a cube root. I may or may not put anything under there, but in this case I will put something under there. I have one set of 3, so I'm going to have 1 3 on the outside. I have 1 2 left over. Do I have anything else left over? No, so I'm just going to have the 2 on the inside so far. So is anybody confused about what we're doing? If a 3, if it's a cube root, there'll be a 3 on the outside of the radical. That means I want a set of 3. And what's that going to mean? I'm going to do with these exponents. I'm going to divide them by 3. Now, can I divide 2 by 3? No. So, what do you think I'm going to do with that?
Put it back in the radical.
So I'm going to leave x squared under there. Because really what that, like if you did it like you done when you first learned to divide. Alright, it goes in there 0 times. You technically put a decimal there, but we don't want to do that. So that would be 0, 2. Our remainder would be 2. Right? And our remainder tells us our exponent on the inside of the radical. So our remainder would be 2. Out here you'd have x to the 0, which is just 1. 3 times 1 is 3. But that's the reason why all that works out. You don't have to know that. Just know that since 3 is bigger than 2, just leave the x squared underneath. Alright? So now we've got to do the 9. Y to the 9th. 9 divided by 3.
Y to the 3rd.
Y to the 3rd. And then we don't have any y's on the inside. So we're done. I mean, you could write that closer together if you want to, but essentially that's all we're doing. Any questions, comments, concerns? The first thing we need to do in the adding and subtracting, alright, is look at each term individually. I need to look at each term individually and break it down. Now, in this particular case, my signs are not going to change, so if I want to go ahead and write them down, I can. That kind of keep you in order a little bit. What I need you to... So, here we need to break down 27. So, another reason I want you to know 3 to the 3rd is 27. I can break that... Like 8 can be broken down into 3 2s. 27 can be broken down into 3 3s. 64 can be broken down into 3 fours, and then 125 can be broken down into 3 fives, and 216 can be broken down into 3 sixes.
Yeah,
Why
keep
did you
going.
just remember this?
That's as far as I can think of.
Coach, this is recording.
I know. But it'll be on there, dude. It'll help you out. Okay. So, 3, I have one pair of 3s. I already have a 4 outside the radical. I want to multiply it by the pair of 3s I'm about to pull out. Alright, and then there's another 3 on the inside that's going to stay on the inside. So that's the first radical I wrote down. The second one is 3 root 3. Can I do anything with 3 root 3?
No.
No. So I'm just going to bring it straight down. Then I got to break down 48. 48 that's why we talked to 16 and 3. Or 6 and 8. But 16 and 3 is the more popular thing you need to know. Like 16 and 3 you need to know is 16 times 3 is 48. Well, 16 is a perfect square, which helps us with this. And I can use this example to show you. I have a pair of 4s right there, correct?
Yeah.
So I can stop there. I don't have to break down those 4s anymore. I could break down the 4s into 2 and 2, 2 and 2. And I'd have 2 pairs of 2. I'd have 2 times 2 out here, but I can just say I've got 1 pair of 4s and pull a 4 out. Have a 3 left over, so a 3 goes underneath the radical. So has anyone got any questions so far? Anything I've done? So then from here, 4 times 3 is 12. Alright? Can I combine all of these?
Yes.
Because they all have the same radical. They're all square root of 3, so I can add them just like I would add 12x plus 3x minus 4x. I'd add them the same way, except instead of x, I've got a square root of 3. So it's 4 times 3 is 12. 12 plus 3 is
15.
15 minus 4,
11.
11.
I thought we all right one.
You're doing it. I feel so proud.
Okay. So if we want to use FOIL, you want to call it that, that's fine. You multiply the 2 first numbers together, so that's the square root of 5 times 2 root 2. I'm sorry, this was supposed to be a 5.
Oh my gosh, I had a 5 and I erased it.
I'm just going to write it in blue. That was supposed to be a 5, I'm sorry. I wrote the problem down there. Okay, so I've got 2, because I need to multiply the front numbers together. There's not a number in front of this 5, so it's just like if there was there wasn't a number in front of x, we'd say it was a 1. So there's a number in front of this 2. There's not a number in front of this, so it's 1. There's a number here, which is 2, so 2 times 1 is 2. So that's where the 2 comes out front. Then when I multiply square roots together, I can put them all under 1 square root.
25.
So 5 times 5. And you could put 25 if you want to. That's just up to you. I'm going to leave it like that, because then I already got a pair of 5s for later on. Right, so that's first in the FOIL. That's the F in FOIL.
I did that.
Then the 2 outside numbers. All right. Now, this is important. What sign goes in between there? That should be first.
A plus.
It's plus, but Y is the important part, because it's positive times a positive gives me a plus right there. It's not because this sign's plus. That has nothing to do with it. It does have something to do with it, just not directly. Okay, so now we have this. We have a 4 out front. Over here we have a 4 out front. Have nothing out front here, so I've just got a 4. Then I have the square root of 5 times the square root of 2, so I put that all under 1 square root and have 5 times 2. So anybody confused on this first 2 steps of FOIL? Next step of FOIL, the 2 inside numbers. Alright, here, what's my sign going to be?
Negative.
A negative sign, because I have a negative times a positive. Gives me a negative here. So, they both have numbers out front. So, 3 times 2, yeah, 6. And then another way you could just do it, negative 3 times positive 2 is negative 6, and that gives you your sign. Then, the square root of 2 times 5. Any good questions on that step? Then our last step, we multiply the two outside numbers. Or the two numbers last. Sorry. The two last numbers. Last number in each set of parentheses.
Just go back to first.
Okay. So we've got a negative times a positive, so I gotta have another minus sign there. Then 3 times 4 is 12. The square root of 2 times the square root of 2. Is anybody confused on where I got the green from? Okay. So now just go back through and simplify everything I can. So that's 2. I have a pair of 5s. So I'm going to have one. I'm going to have a 5 outside. So I'm done with that one. Then I've got a 4. I don't have a pair here, so I just need to multiply them together and stick it under the radical. I have a 6. There's no pair in this square root, so it's root 10. And then in this last radical, minus 12. I have a pair of 2s, so I need to pull a 2 out. Okay, then I just need to simplify stuff. Got 10 plus. Can I combine those two?
Yes.
And what am I going to get?
Negative 2 root 10.
Negative 2 root 10. And then negative 24. What else could I combine? First, let me stop here. This addition and subtraction. So if I can combine the 10 and the negative 24 to give me negative 14. Since that's plus the negative, it's the same thing as minus 2 root 10.